of equations. All right, so hopefully you remember from Algebra 1, Algebra 2, how to graph pretty much everything, right? You can make an XY table, put X's in there, plug X's into your equation, get Y's, that gives you points. We plot the points, we connect the dots, we make a graph. In this class, we're going to have more varied graphs than what you've seen in the past. So you've done a lot with like lines and parabolas, for example, but we're going to see polynomials, so third power, fourth power, fifth power equations. We're going to see exponential equations, logarithmic equations. We're going to see parabolas that open sideways instead of up and down. So lots of different ways our graphs can look. If you're not sure how your graph is supposed to look, you want to make sure you use more points. The more points you use, the more accurate your graph is going to be. For example, I've got the same 3 points on each of these graphs here. There's lots of different graphs that mathematically are correct for this class that I could use these points for. So I could make like a cubic function could look something like this. That's a type of graph that we're going to see. I could see a exponential equation like that. Maybe you guys have seen those before. I could see a parabola, something like that. I could even take the top half of it and it might be a square root function. Okay, so lots of different things I could do here, and the 3 points maybe don't make it as obvious as what I should have. So more points the better is kind of like the moral of the story here. First thing we're going to do is practice just making an XY table, plotting points, getting a graph. Now, before I do any of that, can anybody tell me just from this equation what shape you should expect to get for this graph, like context clues? Not a line. A U. It's going to be a parabola. It's our official name for that, okay? Can anybody tell me if their parabola, their U, is going to open up or down? Again, context clues from the equation here. What do you think? So it's going to open down. It's going to open down because of that negative in front. I know it's going to be a parabola, U-shaped because of the square. Okay, so there's a couple things that I kind of know going in, which help me make my points. As far as the x's go, you can pick any numbers you want. I like, at least to start, -2 to 2. Gives me some negatives, gives me positives, 0. Special things happen sometimes, so that's always good. You can always extend your numbers one way or the other. These are nice, pretty numbers to plug into an equation. So that's nice and easy. We don't necessarily need a calculator for that. Okay, so we're going to plug them in. Make sure when you plug them in, you use the order of operations. So order of operations is parentheses, which I don't have in my equation. The next thing I do is exponents. So that negative, think of that negative in front of the x like a -1 that's hanging out there, okay? It is multiplied by my x. I do not do multiplication before exponents. So the first thing we're going to do is plug this number in and square it. Then we're going to multiply by -1, and then we're going to add 1. So let's do -2. We can do this in our head. We do not need a calculator. -2 squared is 4. Make it negative. -4 plus 1. -3. Plug -1 in. -1 squared. 1. Make it negative. Plus 1. 0 squared is 0 times -1 is 0 plus 1 is 1. Plug in 1. 1 squared 1. Make it negative. -1 plus 1. 0. And 2. 2 squared is 4. Make it negative. -4 plus 1. -3. And then we plot our points. Left, right first, up, down second. -2, -3. -1, 0. 0, 1. 1, 0. 2, -3. We always want to connect our dots, our points, with a smooth curve when possible. And then, even though our table doesn't go further, we know this graph is going to continue to go further in either direction. So we want to make sure we put arrows on the end of it to show that it extends down and out forever. If you want to check it, you can always check it with your graphing calculator. Questions there? Making a graph, just XY table, any type of graphs. Okay, next we're going to review x-intercepts and y-intercepts. An x-intercept is where we graph, or my graph touches the x-axis. A y-intercept is where my graph touches the y-axis. We talked about this in one of our problems yesterday. They always have a certain form when I have a point on the y-axis or a point on the x-axis. Any point on the x-axis will look like the following. It'll have a y-coordinate of 0. Any point on the y-axis will be the opposite. It will have an x-coordinate of 0. So that's actually how we will algebraically solve without a graph for an x-intercept or a y-intercept. If I want an x-intercept, I plug 0 in for y. If I want a y-intercept, I'm going to plug 0 in for x, and then you can solve for the variable that remains. Okay, so let's go ahead and try that. So this is what I just said. X-intercepts, we're going to plug 0 in for y. Y-intercepts, we're going to plug 0 in for x, and we're going to do that with our quadratic here. So this is a parabola. Let's see what we get. Let's start with y-intercepts. Those are usually easier to solve for. Okay, so I've got y equals 2x squared plus 3x minus 2. If I want to find a y-intercept, so a point on the y-axis, what do I plug in? 0 for x. Think about it. We already know half this point. The x is 0. The y is what we're looking for. That's why we're plugging 0 in for x. All right, if I plug 0 in for x, it looks like y equals 2 times 0 squared plus 3 times 0 minus 2. What does that give me? Y equals -2. So sometimes when you solve for a y-intercept, y equals -2 is sufficient. Be careful in Math XL. They might also ask for the coordinate, so you would fill in that whole point. 0, -2 is the point on the graph that is crossing the y-axis. Okay, and then x-intercepts. X-intercepts are when y is equal to 0. So we plug in 0 for y. And then we solve for x. Okay, so we have a quadratic. We're going to see a lot of those this semester. I will tell you they pop up in like every single chapter. Even when we get to like trigonometry, there's going to be quadratics, okay? So number one, quadratic, if you have two different x terms, which we do here, we want to either factor or use a quadratic formula. To do either of those, it needs to get equal to 0, which this one already is, so that's great, okay? Now, because there's a number in front of my x squared, it's not really a super easy factoring problem. You can factor it by guess and check if you've done it that way. Box method, maybe some of you have learned. What other ways have you factored? What did your teachers call them? Were those the two big ones? Like guess and check or box method? Maybe. Worst case scenario, quadratic formula, right? Do we know our quadratic formula? Do we need to maybe put it on the board just to make sure? I expect that you have your quadratic formula memorized. If not, look at YouTube videos of songs of the quadratic formula. It's an excellent way to memorize it, get it stuck in your head. All right, so there's our quadratic formula. All right, with your partner or a friend near you, I want you to either factor this and solve for x, or use the quadratic formula and solve for x. Go ahead. I'll give you a few minutes. Should be two answers to this. Okay, so not every quadratic is factorable. Sometimes they're prime. If you did the circuit training, you saw that word. This one is factorable. It factors to, let's see, 2x times x would multiply to get a 2x squared. Two numbers in the back need to multiply to -2. So it's for sure a 1 and a 2. We just have to figure out which one's positive, which one's negative, and where the 1 and the 2 each go. Let's see, if I put a +2 here and a -1 there, that should do it. And here's how I know. I can FOIL real quick to make sure I factored that correctly. First terms, give me 2x squared. My outside terms are 4x, and my inside terms are -1x. And putting those together gets me my 3x. So your outside plus your inside should be your middle, and then your last terms should be your last. Then once you have it factored, you set each factor equal to 0. If I set 2x minus 1 equal to 0, I will get x equals a half. If I set x plus 2 equal to 0, I will get x equals -2. And if you plug those back in, if you plug 1/2 in for both x's or -2 in for both x's, you should get 0. So you can check your own answer. Now, that's kind of the guess and check way to factor. I don't love the guess and check way, honestly, just because these numbers are pretty small, little, low, easy numbers. There's not a lot of possibilities, but we can get some pretty kind of gross numbers with this. So let me do I call it the box method. Maybe your teacher called it something else. This is more of a methodical way to do it. Grouping, does that sound familiar? Factor by grouping? Okay, let's do that. Let me insert another page here. There we go. Okay, so we got 2x squared plus 3x minus 2. Let's say I want to factor that, okay? So you multiply the first and the last numbers together. What does that give me? -4, okay? Then you try to find two numbers that multiply to -4 and add to your middle term 3. So what two numbers multiply to -4 and add to 3? Good. 4 and -1 would work. Okay, so what do I do with those numbers? Your first number stays the same, your first term. Your last term stays the same, but our middle term is going to be split now into a 4 and a -1x. Now, if I put those together, 4x minus 1x is still 3x, so it's still the same equation, okay? But now I've created 4 different terms because I split that middle term, so I can factor by grouping. What do the first two terms have in common? 2x. And what's left? X plus 2. You guys did that on the skills test, right? Factor out a greatest common factor, something they have in common. We're dividing it out when we do that. What do the next pair of terms have in common? -1. If I factor a -1 out, what am I left with? X plus 2. If you get the same parentheses twice, you're doing good. That first, well, I guess that parentheses, it repeats, I guess, is your first factor, x plus 2. Your other factor are the pieces you took out, 2x minus 1. And you can always FOIL to make sure you did it correctly. It'll take you right back where you started, okay? If you did the quadratic formula method, quadratic formula is going to be inevitable. There are going to be things this semester that cannot factor, and you are going to have to use a quadratic formula. It always works, which is great, but it takes a long time. So I wouldn't say that even though it always works, this is going to be like the route you want to go all the time. It's going to be very tedious. So if I use a quadratic formula, it should look like the following. Opposite of b is -3, plus or minus the square root. B squared is 9. Should always be a positive number there. -4 times my a value is 2 times my c value is -2. All over 2 times a, 2 times 2. So a is a number in front of the x squared, b is a number in front of the x, c is a number by itself. I simplify underneath my square root. That will give me, what does that give me? 16, 20, yep, thank you. All over 4. Square root of 25 gives me 5. That one's nice and pretty. I don't have to break down my radical. And then you can simplify 2 times, once with the plus and once with the minus. If I simplify with the plus, -3 plus 5 gives me 2 over 4, gives me my first answer of a half. If I simplify with the minus, -3 minus 5 gives me -8 divided by 4, which gives me the other answer of -2. So quadratic formula doesn't give you the factors, it takes you straight to the answer, which is nice. Okay, so there's a few different ways to do it. Guess and check, grouping. If you did the box method and you want to do that, that's fine. It's kind of similar to grouping. Quadratic formula, that is your quick review of factoring. That's pretty much all the review of factoring we're going to do for the rest of the year. Okay, hope that helped. If not, Khan Academy is a great option if you feel like you need a little extra help beyond that. Okay, guys? All right, we're just going to do one of this problem, either the x-intercept or the y-intercept, because you're going to see one on MathXL, and I think an example is going to be helpful. So I'll let you guys choose. It's about the same amount of work. Do you want to do the x-intercepts or the y-intercepts for this problem? What sounds good? What are we feeling? What do we think, Grace? X? X? Okay. Let's do x-intercepts. Okay. If I want to find an x-intercept, what do I plug in?
0 for y.
0 for y. All right, so that looks like the following. X minus 2 squared plus 0 minus 3 squared equals 72. I'm hoping this looks a little familiar with some of the distance stuff we did in the last section. Are you guys kind of seeing the same like format here? Okay, so let's see what we can simplify. 0 minus 3 squared, I can for sure simplify that. What does that give me? 9. You do not have to factor or use a quadratic formula here. There is one x, get it alone. How do I get this x alone? First step. Get the x by itself. Before the square root. Subtract 9. So we're going to get 63. Now, because the squared is that whole side of the equation, now we can take the square root. All right, so we're going to do square root of both sides, like so. On the left, it cancels. On the right, I don't want to forget my plus and minus, but square root 63 is something that can break down. What perfect square divides evenly into 63? 9 times what? 7. Okay, so I can say it's square root of 9 times square root of 7, but square root of 9 simplifies to what? 3. So 3 rad 7 is how we're going to break that down. And then you can't do any more than that as long as you want to keep it an exact answer. Last step is I want to move the 2 to the other side. 2 plus and minus 3 rad 7. So if I wanted to list points that were the x-intercepts, there are 2 of them. Both of them have a y-coordinate of 0. One of them is 2 plus 3 rad 7, and the other is 2 minus 3 rad 7, which you could get a decimal approximation of those and look at a graph to see if it matched up with where it's supposed to be crossing the x-axis if you want. If we did the y-intercepts, it would look almost exactly the same as far as steps go. You'd just be plugging 0 in the other parentheses. Okay, so you'll see a couple of those on your homework. All right, next we're going to talk about symmetry. So you guys probably did symmetry in geometry. Symmetry means it looks the same on either side of a mirrored line, right? Do you guys remember doing that in geometry? Okay, so we're not worried about all types of symmetry in this class. We're worried about symmetry that will eventually apply to functions. So there's 3 main types. We're going to have symmetry to the y-axis. So this is an example of a graph that's symmetric to the y-axis. If I reflect it over the y-axis, it will land on top of itself. It looks exactly the same, so we say it's symmetric. This side is a mirror image of this side. We have symmetry to the x-axis, so that's where it's up and down symmetric, flipped over the x-axis. And then we have symmetry to the origin. So this actually is symmetric to both the x and the y-axis. There's been 2 reflections that were made. I think it's easier to remember with symmetry to the origin. Visually, what that is going to look like is it's going to look like a rotation of 180 degrees is symmetry to the origin. So basically, you take your image and you rotate it halfway around, or you flip your paper upside down. If I do that, which I can maybe do that on this picture, let's see. If I flip this picture upside down, there we go. It looks exactly the same. Okay, so that's how I know I have symmetry to the origin. Okay, now we can look at a picture and say, yeah, that's symmetric to the x-axis, the y-axis, or the origin, but we want to be able to do it mathematically. We don't want to just look at it and say, yeah, I kind of think it is, because who knows, maybe for this picture, if on this side it kind of goes out this way, if I extend my graph further, and if this side it goes this way, then it wouldn't be symmetric anymore. What we're seeing in a picture is just maybe a small image if a graph goes on forever in some direction. So we want to make sure it works for all points, not just the part of the graph that we're seeing. So to do that, we're going to look at what actually happens to the points when I flip over the x-axis, y-axis, or origin. Let's say I have a point like 3, 4. And I take that point and I flip it over the y-axis. It's still going to have a y-coordinate of 4. The height didn't change. What changed was my x value, and it changed from a positive 3 to a negative 3. So in general, we can say if I have coordinates that are symmetric to the y-axis, the x coordinates will be opposite. So we're going to use that fact. Symmetry to the y-axis we're going to use the opposite of x. I would write that down, okay? Symmetry to the x-axis is going to be the opposite. If I have the point 3,4 and I flip it over the x-axis, if I flip it down, it's still going to be at 3, but now my y is going to change sign. So we're going to use the opposite of y when we test for that symmetry. The third is our origin. Remember I said symmetry to the origin is the same as a graph that's been reflected over both axes. So we actually are going to use both the opposite of x and the opposite of y. If you look at a set of coordinates like 3, 4, both coordinates will become opposite when we have that type of symmetry. Both the x will be negative and the y will be negative because we're reflected over both axes. Okay? So we're going to do an example of that in a second here. Everybody have that written down? Y-axis, we use negative x. X-axis, we use negative y. Origin, we use both. Negative x and negative y. That's what's happened to my points. Let's just talk about this one at the top. You don't even need to write it down. Can you guys tell me that picture on the top right, does that have symmetry to the x-axis, y-axis, or origin from the picture? X-axis. So the x-axis is our horizontal axis. If we take that picture and we flip it up and down, or above the x-axis and below the x-axis, it looks exactly the same. That's our line of symmetry. Okay, good. Those will be easy homework problems. Just looking at a picture and naming the symmetry. The ones that are going to be a little harder are like this, okay? Could you even graph this in the calculator? No, because the y is not alone. And if you get the y alone, it's a whole big mess, and it's not even going to give you an accurate picture there. Could you put this picture in Desmos and look at the picture? Absolutely. Is that going to save you so much time on your homework? Yes. Is that a way to check your answer? Yes. Do it. Go for it. Are you going to have Desmos when you take your test in this class? No, you are not. Am I going to ask you a question like this and expect you to show your work on the test? Yes, I am. Okay, so if you want a shortcut on your Math Excel, I'm not going to know, but your test scores are going to show that you're not practicing it how you should be. So that's up to you guys how you want to use those resources. I know they're available. I know you have access to them. Just cautionary tale there, okay? All right, I have an equation. I want to test this equation for symmetry to the x-axis, y-axis, and origin. This is almost going to look like a proof, okay? We're going to show work, 3 columns. One for each, x-axis, y-axis, origin. Okay. And we just said what we're going to plug in to test for each. We're going to do this 3 times. To test for symmetry to the x-axis, I'm going to plug in the opposite of y. To test for symmetry to the y-axis, I'm going to plug in the opposite of x. To test for symmetry to the origin, we're going to plug in both. If, when I plug those values in, I get my original function back out, that tells me that we have symmetry. If I get anything other than my original equation, we do not have symmetry. So that's what we're looking for. Let's start with the x-axis. Plugging in negative y, it goes in for my y's. My y's are replaced with negative y's. So here's what that would look like. X squared minus, take y out, put negative y in its place, squared equals 1. So y comes out, negative y replaces it, and we simplify. Negative y squared, that means negative y times negative y. What is that? It's just y squared, and there's already that minus. Is that the same as my original equation? Yes. So do we have symmetry to the x-axis? Yes. There should be a minimum of 3 lines for each of these. Plugging it in, simplifying, yes or no. It's going to be our format, okay? Symmetry to the y-axis. We're going to replace the x's with negative x. So that looks like negative x squared minus y squared equals 1. Negative x squared, will that be positive or negative? Positive. Is that the same as my original equation? Yes. We have symmetry to the y-axis. Symmetry to the origin, plug them both in. We replace x with negative x. We replace y with negative y. Negative x squared minus negative y squared equals 1. Negative x squared, positive or negative? Positive. Minus negative y squared. Will that term be positive or negative? If I have minus negative y squared, it's going to be negative, ultimately. Same as my original equation. All three were yeses. So in Math Excel, this might be like a multi-select question instead of just multiple choice. Yes? Is it possible for the x-axis, y-axis? Yes. No, that is not possible. So if you have symmetry to the x-axis and the y-axis, you automatically have symmetry to the origin. And you could state that on that third line. You could say because there's already symmetry to both of those. Yes. Now, is it possible to be a no, yes? Yes, that's possible. It could be not symmetric to the x-axis, not symmetric to the y-axis, but it could be symmetric to the origin. So you just want to be careful that if you're not going to do the lines of proof, that you are justifying it with a statement at least as to why that's possible. Okay. All right. Let's see what I want to do here. Yeah, let's have you guys do this one. So with your partner, make your 3 columns. I want you to test this function for symmetry to the x-axis, y-axis, origin. Hey, any negative number to an even power, what is that? Any negative to an even power is positive. And any negative to an odd power is negative. Okay, go. Let's check. X-axis is a no, y-axis is a yes, origin is a no. Any questions? Yes.
If two get a no, is it automatically for origin?
Only if it's a yes and a no. If you get 2 no's, it can be a yes. And let me show you an example. Actually, that was my next example. So all we're going to do for this problem is do the origin. We're not going to do the x-axis or the y-axis. I promise you, you can trust me, x-axis and y-axis are a no. Okay, you can imagine like x-axis, if I put negative y in there, it's just going to look different. That's it. It's a no. Let's do the origin, though. Okay, so the origin, I'm going to plug both in. Negative y equals negative 3 times negative x to the 5th plus 2 times negative x to the 3rd. Okay, so simplifying, negative x to the 5th, that's negative, times negative 3, that whole term will be positive. Okay, that's the only thing that's changing are my pluses and minuses. Negative x to the 3rd, negative, times 2 will still be negative. That's different. But here's what I can do. I can take this whole equation and I can multiply both sides by -1, or I could divide both sides by -1. And it's going to flip all my signs. Everything's going to be the opposite. Y equals negative 3x to the 5th plus 2x to the 3rd. So it's a no, no, and the origin is a yes because of that. So that's an option. Rather than just simplifying, you can multiply or divide both sides by a -1 if you notice that all these signs are opposite. Now, why does that happen? If you look at this picture, now this isn't exactly what this picture looks like, but it's similar. It's a cubic function, so it's going to roughly look like this. So could I flip it over the x-axis and it look the same? No. Could I flip it over the y-axis and it look the same? No. But could I flip it upside down and it look the same? Yes. No, no, yes. Make sense? When in doubt, just do all 3 columns of your proof to be safe. All right, there are 2 slides left on here with circles. We're going to save that for tomorrow. So if you guys want, you can start your Math Excel tonight for 2-2. Remember, 2-1 is due tomorrow night by midnight. 2-2 is going to be due on Friday night. So those are your 2 deadlines this week. 2-1 is due Wednesday. 2-2 is due Friday. So you guys can work through that as you like. Remember to send me questions. Use the help option as you're working through them. Cell phone lotto. Who hasn't drawn yet? Drawn yet? Don't look. Don't look. I'm cheating. 2. Should they grab your phone? in the bottom tray there.